Oops. There we go.
Wow. Oh my, what did she just say?
No, actually, I brought it up. I was like, you know, last week. It's like, yeah.
Okay. We're going to be in lesson 6.4, and this is properties of special parallelograms. And so we just go back real quick and we remind ourselves, what is a parallelogram anyways? What has to be true about a parallelogram? Two congruent opposite parallel lines. So this has to be congruent to this. This has to be congruent to this. What else has to be true?
The opposite angles have to be congruent.
Yep, opposite angles have to be congruent. So this angle's congruent to this one. This one's congruent to this one. And then the very last thing has to do with the diagonals. What has to be true about the diagonals? No, not necessarily congruent. Yeah, they have to meet at some kind of a midpoint, don't they?
What does that make them congruent?
That doesn't make them congruent.
No,
For
because
example,
two of the sides are longer than
right, if the parallelogram leans over to the right, then this diagonal here must be the larger of the two.
Right. No, she means on the other side.
Well, yeah, that makes this right here congruent to this right here, definitely. And that makes this right here congruent to this right here. That's absolutely true. So if that's what you were saying, you're absolutely right. Okay? Well, today we're just going to look at some rectangles. And rectangles are a smaller part of the parallelogram family. So they're also parallelograms. They're kind of British. Because if you think of the British are, you know, proper and upright. Hello, cheerio, I'm going to have some tea and whatnot, some crumpets, and play some, you know, play some squash. You know, the British are very, I probably shouldn't put this on YouTube, but anyways, the British are very, you know, they're pretty straight going. They're rigid, is what I'm trying to say. They're rigid, right?
Stuck up.
So, well, I don't want to say that. No. But a rectangle, okay. Oh dear, I can't put this on YouTube now. A rectangle, what makes a rectangle a rectangle?
The angles are not.
Yeah, that's what I meant by they're rigid. That's what I meant by them being rigid. The angles are all 90 degrees. The opposite sides are still congruent. The opposite sides are still parallel. And what about the opposite angles? Are the opposite angles congruent?
Yes.
Yeah, not only are they all congruent, they're all 90, right? Now there's something extra that you get with a rectangle that you don't get with a normal parallelogram, and that has to do with the diagonals. What has to be true about the diagonals? Yeah, that's exactly right, Seth. The diagonals here must be congruent. So if this is A, B, C, D, then that means that diagonal AC must be congruent with diagonal DB or BD. And you don't normally get that in a parallelogram. Because in a normal parallelogram, Elena, they lean over to some side, and that makes one of the diagonals larger than another one. Okay? Now, is it true that if I have a point E right here in the center, is E going to be at the midpoint of the diagonals?
Yes.
You better believe it, because a rectangle is part of the parallelogram family. So you've got this large set of family right here. You've got a family called quadrilaterals. Okay, what makes a quadrilateral a quadrilateral? Four sides and that's it. Four sides and anything goes, right? Inside of the quadrilateral family, you have the parallelogram family. And then inside of the parallelogram family, you have the rectangle family. So what we're doing now is we're talking about what are called subfamilies. Subfamilies.
What about the square?
Excellent question. Hunter just asked, what about the square? And it turns out the square is a smaller family inside the rectangle family. So is a square a rectangle?
Yes.
Absolutely. Is a rectangle always a square?
Not in the least.
Not always, okay? Do you see this idea of families? That's all we're talking about right now. We got these ideas of families, okay? All right, so we're going to get 5 new properties that deal with rectangles, and many of them, 2 new properties with rectangles, and these properties pretty much follow directly from parallelograms. So the first one simply says is that if, this is theorem 641, if you have a rectangle, then, anybody think they know the conclusion? Then you have a parallelogram, or it's a parallelogram. And that's all theorem 641 says. Nothing new. Okay? Theorem 642 says if you have a rectangle, then the diagonals are congruent. The diagonals have the same measure, the same length. Okay? And that's pretty straightforward, isn't it? That makes pretty much good common sense for rectangles. Okay? Any questions up to this point? Okay. Now we've got another kind of object called a rhombus. A rhombus is a parallelogram. It's a quadrilateral, but it's a special parallelogram. All the sides in a rhombus are exactly the same, but the angles at the corners do not form 90 degrees. So it's a square that's been tilted to the side, is what a rhombus is. So I can definitely say that all the sides are the same in a rhombus. All sides are congruent, just like a square, but what I can't say, Alexis, is that the angles are 90. That's off. That does not work, okay? However, I can say that opposite angles are congruent, and that's from the fact that it's a what? It's a parallelogram, so opposite angles have to be congruent. There's no way around it, okay? So if you look at theorem 643, that doesn't say a whole lot. It just basically says if you have a rhombus, then you have a what? Parallelogram. So now you know that if you have a rhombus, you definitely have a parallelogram. And any of the theories or properties that dealt with parallelograms also apply to rhombi too at the same time. Theorem 644 says if you have a rhombus, then the diagonals, now don't say anything yet, I'm going to draw another rhombus right here. So here's another rhombus. What would you suspect, look at the picture here carefully, what would you suspect about the diagonals? They're perpendicular. Are they going to be congruent? No, because this thing's leaning over to the side, so one of the diagonals has to be bigger. But it turns out that in the case of the rhombus, you are guaranteed a 90-degree angle there with the diagonals. That is a guarantee. So then the diagonals themselves are perpendicular. And one of the things that you'll need to know how to do as a geometry student is to be able to look at the picture of a rhombus and say, hey, I know that the diagonals have to be perpendicular. And the reason why that's useful, Elena, is because if the diagonals are perpendicular, then I can use the Pythagorean theorem here on any of those little triangles that are located in that rhombus at the same time. And that's why it's useful to know that, okay? So we can use the Pythagorean theorem if I know that this side right here happens to be, let's say, 3, and this side right here happens to be 4, then I can actually figure out what one of the sides of the rhombus is by doing the Pythagorean theorem. 3 squared plus 4 squared is 25. Square root of 25 is 5, so all of the sides of the rhombus would have to be 5. And that's why it's useful to know, I'm not just saying it, that's why it's useful to know that the diagonals are perpendicular. Okay? Does that make sense to you? Okay? Last part, theorem 645. You okay, Hunter?
I just had an accident on my mouth. I tried to muffle it.
You know this is going on YouTube for all posterity, right?
Kidding.
You're online for all eternity after today. That's pressure
Yeah,
right there.
I'm the grotesque kid in the geometry class.
It's all good. We love you. 1, 2, 3, 4, 5, 6. You could show this to your grandkids. All right. That's Grandpa Hunter. He had a bad egg sandwich that morning. All right. Theorem 645. I'll stop. I'm going too far here. If a parallelogram, so if you have a rhombus, if you have a rhombus, then what we can say is each diagonal bisects, that means cuts in half, a pair of opposite angles. Okay, so what's the consequence then? Well, BD is a let me try that again. BD is a diagonal, right? So what it does here, Carl, is it cuts angle B in half. So I now know that angle 1 must be congruent to angle 2. So it cuts this opposite angle into 2 congruent halves. I know that angle 3 must be congruent to angle 4. I know that angle 5 must be congruent to angle 6. I know that 7 must be congruent to 8. Now, is a rhombus a parallelogram?
Yes.
Yes. So from chapter 3 on parallel lines, I also know that angle 7 has to be congruent to angle 3. But how do I know that? How do I know that angle 7 must be the same as angle 3? Think of this as line BC, and this is line AD, and they're parallel. Not corresponding, but now we're getting closer. Alternate interior angles. So 7 has to be congruent to 3 by the alternate interior angles theorem. Which also means, by the way, that 8 has to be congruent to what? 8 has to be congruent to 4. 1 has to be congruent to 5. 2 has to be congruent to 6. And I think there's one that I've forgotten. 1, 8 and 4, 5 and 6. 3 has to be congruent to, I already said that, 7. Right, so that gives 1, 2, 3, 4, 5, 6, 7, 8. Yes, that gives me them all. Okay, so we've got something nice. This is the theorem. It's pretty easy to understand, Kelsey, but that's the theorem that it's easy to forget, that sometimes we need the most. Okay, so you need to know that the diagonals cut these opposite angles perfectly in half. You can actually use that as a theorem, and that's an easy one to forget. Okay, easy to understand, but also easy to forget at the same time. Okay, so here's what we want to do. I've got some ordered pairs. Let's say I've got A is located at -1, 0. B is located at -3, 5. C is located at 2, 7. and D is at 4, 2. And what I want to do is to show that ABCD is a square. I want to show that this is a square. Well, now let's think. What makes a square a square? All four sides are the same, but we've already got something else that has all four sides the same.
All four angles are 90 degrees.
All four angles are 90 degrees. So now I simply ask the question, is it enough to show that all four sides are the same? It's not, because what else has all four sides the same? Rhombus. So does that make sense to you? So not only do I have to show that all four sides are the same, I've got to show what?
They're all 90 degrees.
All 90-degree angles. Okay, so let's go ahead and let's graph this out. So negative 1, 0, there's A. 2, 3, 1, 2, 3, 4, 5, there's B. 1, 2, 1, 2, 3, 4, 5, 6, 7, there's C. And 4, 2, there's D. Okay. So, first thing on the agenda, let's show that BC has the same distance as AD. Okay? So what is the distance of B to C? Well, it's the square root. Set up the problem. Let's go to point B. Negative 3 minus negative 1. 5 minus 0. Okay? What's negative 3 minus negative 1?
Negative 2.
Negative 2. Square that. 4. 5 squared.
5.
Add them together. So this is the square root of 29. Now let's find AD. The distance from A to D is the square root. Set up the problem. So D is 4 minus negative 1. 2 minus 0. Okay, what's 4 minus negative 1? 5. 5 squared? 25. 2 squared? 4. And do you see that we get the same thing? So this is definitely congruent to that. Now, I could go ahead and do the same distance formula for C and D, but I think you already see how that would work, right? Now let's just show that CD is perpendicular to AD, so I need to find the slope of CD. So I find the rise and the run. So here's C, 7 minus 2 over 2 minus 4. And what does that give me on the top? 5 over negative 2, right there, there's the slope, okay? Now let's find the slope of AD. Okay, that's going to be 2 minus 0 over 4 minus negative 1. But that gives me 2 over 5. Well, wait a minute. This is negative 5 halves, and this is 2 fifths.
So B1.
So when you multiply them, what do you get? If you take negative 5 halves times 2 fifths, negative 1. And you know that two lines are perpendicular if you multiply their slopes and get negative 1. That's how you can know that they're perpendicular. Or, what's another way of saying that, by the way? The slopes are opposite reciprocals. That's how you can know. So now I know that this is 90 degrees. Well, once I've shown that, by the way, if I can show that BC has the same slope as AD, then I can use one of the theorems from 6.3. Because they're opposite, parallel, and they're congruent, and that's enough to show that it's a parallelogram. So that means that this angle has to be congruent to this one, because they're opposite angles, right there. Find this angle, you're going to show that that's 90, and it's congruent to this one. And then that would be enough to show, once you find these two sides, that actually all sides are the same, that it's going to be a square. Okay? So I did that problem because I want you to avoid a certain trap. I don't want you to think that it's just enough now to show that all four sides are the same to show that it's a square. Does that make sense? That's why I did that problem. Plus also to reinforce the distance formula and the perpendicular slopes. Okay? Questions, comments, concerns? You don't like my shoes? Anything? Does the lesson make sense a little bit more now, Elena? Okay. All right. Here's what we're going to do. I'm not going to assign a homework out of 6.4 tonight. Okay. We're now going to start taking notes for the midterm. Okay. The first thing I want you to do
Oh, if thens. Now I remember this. Sort of. Kind of.
I'd like you to write this out on note paper. We're going to take notes now for the midterm. If you live in Bangor, then you live in Maine. One of the things that you have to be able to do is to tell me what's the hypothesis and what's the conclusion. So this goes back to chapter 2. That's where we are right now. Good old chapter 2. And what I want you to be able to tell me is, what is the hypothesis to this? What'd you say? Then you live in Maine? Nope, that's the conclusion. If you live in Bangor, but you don't need which word? Right, so the hypothesis is simply what? You live in Bangor. So we're going to underline the hypothesis one time. Okay, what's the conclusion? Just you live in Maine without the then. So you underline that twice, and that's the conclusion. Okay. Now, what we want to do first is we want to test the truth value of this. Is this a true statement or is this false?
The true statement.
Okay, if we're only talking about Maine, it's a true statement. But there are other places that are called Bangor. So realistically, we'd have to say that this is false. But I could make something that would have to be true, right? I would say if you live in the United States, then you're on planet Earth. Right? So that at least, hopefully, for conversation, for a realistic conversation, something that doesn't get too crazy and wild and paranormal, you could say that that's true, right? Okay. Now, one thing that you have to be able to do for the midterm is you've got to remember how to take the converse of something. How does one take the converse? What do you do? Simply switch the hypothesis and the conclusion. Do you switch the if and the then? No. You don't. And for you guys, this will be online.
Oh, hold on.
Okay? So, what would the converse say? If
you live in Maine.
Right. If you live in Maine, then you live in Bangor. And now what we have to do is just to test the truth value of that. Is that true? Not necessarily. So this is also false. Good. All right. You've got to remember how to take the inverse of something. So how does one take the inverse correctly of something? You take the opposites. Do you switch?
No.
Not yet.
You don't switch. So all you're going to do is you're going to take the opposite of the hypothesis. So what's the opposite of you live in Bangor? If you don't live in Bangor, then you don't live in Maine. So is this a true statement?
No.
Right. I live in Corinth. So do I live in Maine? I do. So this is not a true statement. This is false. Does anybody remember what the last one is called?
Contrapositive.
You got it. Now, how is the contrapositive different from the inverse?
You switch them in.
You switch them and make them negative. So go ahead, Jasmine, tell me what the contrapositive is going to say.
If you don't live in Maine, then you don't live
That's perfect. If you don't live in Maine, then you don't live in Bangor. And is that a true statement? No. So it turns out in this case that they all turn out to be false. Will they always turn out to be false? No. Some of them will turn out to be true and others will turn out to be false. And there are certain situations where they all turn out to be true. There are special situations. So you have to think carefully, okay, about whether something can be true or false. All right? Does that make sense so far? So you will be asked to take something like this, to underline the hypothesis, double underline the conclusion, and then find both the converse, inverse, contrapositive. One thing that you guys have done really well in the past on your quizzes and tests is you found the converse, the inverse, and the contrapositive. But where this particular class is a little bit weak is that you tend to forget to find the truth value also. You need to remember to do that, okay? I will ask you that definitely 100% on the midterm. Hey, find the truth value also, okay? So just be on your toes for that, okay? All right. Now, as far as Chapter 2 is concerned, that's all I'm really concerned about in Chapter 2, okay? Next thing we need to know. We need to know 100% our special right triangles.
This chapter 3.
This actually skips all the way now to Chapter 5. Special right triangles. This is such an important section, you'll see it again on the final. And if you haven't taken your SAT or ACTs yet, you definitely will see them in there, okay? So we've got two kinds of special right triangles. The first kind of special right triangle is called a,
Right triangle.
it's always a right triangle. A 45, 45, 90. That's exactly right. And what do I know about the legs of a 45, 45, 90?
They are congruent.
They have to be congruent. So what we're going to do, Devin, is we're going to call them n to represent that they're the same length. What is the hypotenuse?
N squared.
N square root of 2. That's exactly right. So what you need to be able to do for me is I need to be able to give you any side of that right triangle, and you can find me the other sides. So here's a case. Let's say that this is a 45, 45, 90, and that this side right here is 5 square roots of 2. How much is x and how much is y? Well, x has to be what?
Square root of 2.
It must be. There's no other choice. Because, by the way, a 45, 45, 90 is also what kind of a triangle? Isosceles. If you have a 45, 45, 90, you definitely have an isosceles triangle. Now, what does y have to be?
5 square root of 4.
5 square roots of, I'm gonna write it like this, but you're absolutely right, Devin. 5 square roots of 4, I'm gonna write it like this. So this becomes 5 square roots of 4.
Which is
But-
5 times 2, which equals 10.
You got it. So the hypotenuse has to be 10. Okay?
Would you be okay with us leaving 5 square roots of 4?
I wouldn't, because square root of 4 is a perfect square, and it's reducible. And you would be expected to know, coming out of high school or walking into an SAT, you'll be expected to just know how to reduce it. That's why I have to say I wouldn't accept it. Okay? So this is equal to 10. What's the other kind of special right triangle?
36.
30, 60, 90. Okay. Which side of the triangle has to be the shortest?
The leg.
And
this one right here, because this is located where? Opposite
The largest angle.
The smallest.
What is it?
It's this side right here is opposite the
Smallest.
30 degrees, the smallest angle. So therefore it has to be the smallest side. What is the hypotenuse going to be?
The longest.
Not n squared, 2n. The hypotenuse is always twice as much as the short leg. What is the middle leg, the guy that's in between?
It's like n squared.
N square root of, you're close,
3.
3. Okay? Let's go ahead and list these in order. Out of the 3, which one's the shortest side?
N.
N. What's the middle guy?
N squared.
N square roots of 3. And then the longest?
N 2.
2n. This right here is the hypotenuse. This right here is the shortest side. And this guy is the side that's opposite the 60 degrees. Opposite this. And that always works, by the way, for a 30, 60, 90. 100%. That's just always the case. Okay? Okay, so I gave you a 30, 60, 90. And this right here is 9. All right, we want to find the other two sides of the triangle. So if I know that this is 9, what do I do now to figure out the shortest side, which is x? I set 9 equal to n square roots of 3. Yes, that's exactly right. I divide everything now by the square root of 3. So this becomes 9 over the square root of 3 equals n. And what has to happen here? Not by 2, no. What do we call getting rid of the radical from the denominator? Rationalize. So how do we do that?
Square root of 3 over square root of 3.
Yes. We add a square root of 3 above and a square root of 3 below. So the numerator becomes 9 square roots of 3. What does the denominator become? Square root of 9, but 9 is a perfect square.
So it would be 3.
So it becomes 3, and now 9 is divisible by 3.
So it would be square root
3 square roots of 3, because 9 divided by 3 is 3. So that means that this side right here is 3 square roots of 3. Does that make sense to you?
Yeah.
Okay. Now, to get the hypotenuse, all you have to do is double the shortest side, which we found. So will this be 6 square roots of 6? No, that's exactly right. What will it be? 9 square roots of 9? Nope, that's not doubling. See, to double is simply to multiply by 2.
So it would be 6 square root of 3.
There you go, 6 square roots of 3. So when you double a root, you can't double the actual root. You have to double the number outside the root. So 6 square roots of 3 is the hypotenuse. Okay? Does that make sense? Okay? Let's just do a little bit of practice with rationalization. So we're going to practice some rationalization for just a minute or two. If I have 5 over the square root of 2, take just 30 seconds and then write down what you think that's going to become. And your answer will be 5 square roots of 2 over 2, if you rationalize. 10 over the square root of 5, try that one. And your answer there will be 2 square roots of 5. Anybody get that? Okay. Last one, if you have 13 over the square root of 3, and you rationalize that, you'll get 13 square roots of 3 over 3. And you don't reduce that any further, but why?
Because it's not divisible.
Yeah, 13 and 3 don't divide out well. That's why. Now, if you wrote it as a decimal, Devin, you could write it this way. 3 goes into 13 about 4 times with 1 left over. So you could write this, 4.3 repeating square roots of 3. And that, by the way, is exactly correct. So Alexa, if you gave me 4.3 repeating square roots of 3 as the answer, I'd give you full credit. Okay? I just want you to know that if you have something like this, you don't have to. Okay? Does that make sense? Okay? All right, so this is what's going to happen. Remember, Friday I'm giving you what's called a homework. It is a legitimate homework. It's going to go in the grade book as a homework. But I'm also going to give you the solutions. So I want you to try to do the homework first as if it was the midterm, and then go to the solutions. So that means when you turn it in to me on midterm day, which is what day next week? It's right on Tuesday. You can get 100% on that homework because you'll have the solutions. The reason why I'm doing this is so that you have a study guide. Midterm's not on Tuesday? It's on Wednesday? Okay. And if you have any questions, I'll still be here all day on Tuesday, all the way up till after school. So you can definitely ask me any questions if you have any. Okay? Is that fair? I think that's fair. All right. And so I will put this video online. Is there anybody that does not know how to get to the video?
Praise Father, Son. Praise Father.